Hi everyone. So today we are in section in your text 2-3. We're talking about biconditional statements. So in your note packet, I believe that it's page 10. But at the top it says reviewing symbolic notation. So we're going to review the symbolic notation that we worked on in class today. So if I give you a statement that's in the form if P, then Q, with P being the hypothesis and Q being the conclusion, then to write the converse, I would just flip them. So it would be if Q, then P. All right, if I wanted to then write the inverse, remember the inverse relates to the original statement. We negate it. We negate the original. That would give us if not P, then not Q. And then the last one is the contrapositive, which negates the converse. So if not Q, then not P. So we spent a lot of time practicing that today. So let's move on to something else and maybe a little bit easier, making it a little bit easier for ourselves. We're going to be talking about biconditional statements, okay? Biconditional statements. So a biconditional is, let's define it, is a single true statement that combines a true conditional, so a conditional that's true, with its true converse. By using, that looks just terrible, so let me erase that. By using if and only if. So that little statement's going to get plugged into it. If and only if. Now in math we can write that as IFF, so I could use IFF to mean if and only if. All right, so let's talk about this. A true conditional statement. So we know our conditional is true, and then it also then has a true converse. If we find that there's no counterexamples, then we can write it as a biconditional. One thing to note is that all good definitions should be able to be written as biconditional statements. And we're going to talk about what a good definition is in class tomorrow, okay? All right, so let's talk this through. Here's our example. Here's the conditional. If two angles have the same measure, then the angles are congruent. All right, is that true? So if two angles are 20 degrees, then would we say that they are congruent? And we would say that that's a true statement. All right, so now let's write the converse. The converse, we flip it. So if two angles are congruent, then they have the same measure. This is actually the definition of congruent angles. All right, so that tells me, number one, that if it's a good definition, then yes, it is going to give me a true converse. And yes, if two angles are congruent, that means the same size, same shape, then they will also have the same measure, so it is also true. Since I have a true conditional and a true converse, I can write this as one statement, a biconditional. So I'm going to combine them. Two angles are congruent if and only if they have the same measure. Okay, so now I've just made it a biconditional. So the biconditional just makes it a little bit simpler by combining the two into one statement. Now, if you see it, a statement that's got if and only if in it, then you know that both its conditional and its converse were true. All right, let's try one more. Okay, so if 3 points are collinear, then they lie on the same line. So if I want to write the converse, I just have to flip the hypothesis and the conclusion. So if 3 points lie on the same line, then they are collinear. All right, so thinking that through, collinear points are 3 or more points that lie on the same line. And it is, again, the definition of collinear. So no matter what I do, the conditional is true. I can't find a counterexample, and the converse is true. So that means I can write it as a biconditional. All right, so let's do it. 3 points are, and I can flip it around and do it like this. 3 points are collinear if and only if they lie on the same line. All right, so that's our review of biconditional statements today. Tomorrow in class, we are going to be doing a little bit more and extending this as we practice from our textbook. So make sure your textbooks are all ready to go and that you've got them with you. You've got your iBooks with you when you come to class. All right, guys, sorry for the little sniffles. I have a little cold. Have a great night.